Okay, Physics 30s, let's take a look at the first part of the photoelectric effect. Some questions, page 100 of the workbook. Question number 1, the work function for cesium is 1.90 eV. What is the maximum wavelength that can emit electrons from the metal surface in nanometers? What kind of EMR is this approximately? All right, to do a question like this first one right here, what you want to do is know your formulas. Okay, so what we were introduced to before was the idea of the energy of the photon equal to HF or HC over lambda. Okay, so we've seen this before in a previous lesson. With the photoelectric effect, what we have here is conservation of energy, which means that the total initial energy is equal to the total final energy. So the energy of the photon was equal to the energy released for the maximum kinetic energy of the electron, so EK max, plus any work that was necessary to remove the electron from the surface. I think in the formula on the previous page, they had these in the opposite place, but essentially it's the same, right? It's an addition between two terms. They can occur in whatever order. What we're looking at here is the idea of the work function, because that's really what we have here. We have the work function of 1.9 and we want a maximum wavelength, or we'd say a minimum frequency. So really we're just looking at this term. So the work function, just to give you the third formula, like here's the first formula, here's the second formula, okay, and here's the third formula. W each F sub 0, or F naught, or F0, however you'd like to term it, which is really referring to the threshold frequency. Well, there's also a threshold wavelength. Okay, so HC over wavelength, 0. So in this problem, what we want to do is we want to use formula number 3. What maximum wavelength? Let's just rearrange this for the wavelength. So wavelength is equal to the work function, pardon me, HC over the work function. Now, since the work function is given in electron volts, what we want to do is we want to use the Planck's constant in terms of electron volts. So 4.14 e negative 15 electron volt seconds. I'll just put the units in this case here, okay? Just to kind of let you see how the units work out. And then we have 1.90 eV. Now, sometimes there's a little rounding error in this, right, when you use this constant. Because it's only the 3 significant digits. 6.53. 6.54 actually, E negative 7 meters. Well, 6.54 is getting on towards red, which would be 700 nanometers. This is really about 654 nanometers. And so we're getting close to red light, so it might be something just before red light, something like orange or yellow. Okay? Okay. All right, take a look at another question here. Let's look at question number 3. Incident photons with 7.40 eV of energy are shown on a surface, and the electrons are emitted with a maximum speed of 1.12 times 10 to the 6 meters per second. What is the work function of the metal in joules? Okay, so let's take a look at equation number 2 and use that one. So energy of the photon is equal to EK max plus W. And so we know the incident photons have a certain amount of energy, okay? We know the maximum speed, and what we're doing is we're looking for the work function. So let's go ahead and calculate the work function by taking the energy of the photon and subtracting away EK max. Now, energy of the photon is given as 7.40 eV times 1.6 e negative 19 joules for every electron volt. So we're doing the conversion to get it in joules. And now for kinetic energy. So subtract away, I don't have room over here, so I'll just put it down below. 1/2 times the mass. What's a photoelectron? So the mass of an electron, and times the speed, 1.12 E6, and we have to square that. Now notice the units here. This is kilograms, this is meters per second, but we're squaring it, so the unit is in joules. Okay? I didn't put the units in the entire calculation, just showing what the unit is there. 7.4 times 1.6 exponent -19. Subtract away 1/2 times 9.11 exponent -31 times 1.12 exponent 6 squared. All right, 6.13 E -19 joules. All right, I'll do another couple problems in a moment. Thank you.